this is my second time here, and I'm happy to see all of you in the weekend. It takes a lot of effort, not only for the organizer to organize it. I myself also organize a couple of meetups on the weekend when you have demand back at home, and also attending. It's the same effort, right? And just remember that I generally give the talk in the free events because I don't charge for my talk, so I don't go in the paid event unless it is the company which I work for, because they pay me as a salary, so I'm obliged to do that. But even if it is a free talk, it is equal, if not more, effort for an organizer to organize. So let's have a good round of applause for the organizer to really organize this free event. It's a community effort, right, at the end of the day. So what I'm going to talk about is compare the IoT devices which you see today. Now, just to begin with, just to give you some idea, the drill machine you heard some time back, the clicker I have has got microcontroller unit. And every device today which has a screen, light and a button has a microcontroller. And 9 billion of the microcontroller produces every year. 9 billion microcontrollers. And out of which only 1% is connected. Okay? That's the scope of IoT. And that's why big companies are behind IoT. Why is people are crazy about it? Because it's a huge multi-billion-dollar business. Right? So we'll see how microcontroller really plays a key role in this security concept. So I will begin with something called MX chip. So I've got an MX chip, so I just want to show you the view of the MX chip, how it looks like. So MX chip looks something similar to this, so which I have here with me right now at this point in time. So it's a small one, really hard. So I thought I'll take a screenshot and put it here. So you can see that it has got a display and got a couple of sensors inbuilt. Now remember that if you don't come from the electronics background, making these kind of things, connecting multiple devices, joining multiple different wires requires some knowledge. So not possible for everyone, let's be very frank on that. And then there's a display here, and then a couple of buttons to really control things. Now this has got a chip which is Arduino device, so it's open source. You can use Raspberry Pi, anything of that, so it's fine. You can connect this to any IoT package. Now, the main goal of the IoT, the connected device, is that you send the data back to some backend, right? That's what I'm going to do. Now, when you send the data back to the device, now you imagine that it started sending the data using the Wi-Fi right now, just configured. And how you do that, I will just give you an example because this is not what we are focusing on today's talk. We will come back to the next one. So if I come back over here and I see that this comes with something, another module inbuilt into it, a Wi-Fi module. So let's take that Wi-Fi out. Alright, just switch off the Wi-Fi. Okay, I will, yeah, sure. Let me share the device. I'll share the screen. Okay, so I just reshared the device. Let me close this presentation window. It should show up. Yeah, and then in the, you see that there is a new Wi-Fi. This is the Wi-Fi coming from this device. Now, in the display, it is basically showing me the name, right? And that's the Wi-Fi it is picking up. So Wi-Fi module is already built in. So it's a dev kit basically. So you have everything over here. Now once you connect the Wi-Fi device, what it basically allows you to do is that configure this device with some information. The information about the connection. So how when you connect to a database, you need to provide the database connection string, the username and password, like that. If you are connecting to IoT backend, let's assume that you are putting a connection string. So we can add a connection string once it is connected. You'll be able to see a portal. So I'm sure all of you have configured your own Wi-Fi at home, right? When you configure your Wi-Fi, use 192.168.0.1. That's what Wi-Fi connects. And then you have the control panel. Now it doesn't have internet. That's fine. What I can do, I can go to this and just type the IP address, which is displayed over here. So I'm not memorizing anything, so all this information comes from here. So if you type that, it gives you the setup wizard. So it's a basically browser-based thing, just like Wi-Fi router. You see here, it allows you to provide certain information. It picks up all the Wi-Fi it can connect to. So you can see that pro, visitor, pro, guest, and all these things, which I'm already connected, so I'll not go into that. But if you just, let's say, select the Wi-Fi, provide that, and device pin code is available in this device, right? Somewhere in this chip, and it's displayed in this monitor, and the pin code is something. Let's work it out that way. And then I have got an IoT backend, and that backend provides me the scope ID and the device ID and the SAS key. Now what I really mean to say is that if I go back to the portal, and I see that these information are quite human readable, and when I put that in the chip, no encryption happens. So if this chip is compromised, and it's a connected chip, I'm basically exposing my backend. A hacker could do anything, and this has happened in the New York region, and the whole of New York was down for a couple of hours. People had this. So this is not what we are talking about the security, because this is a freely available, human readable text which goes into this device in form of a text. If I have the device with me, I can extract the text programmatically. There is no rocket science required to do that. Let's put it that way. Now you can also have certificate. Now I will show you the certificate option. Now people can argue that what if I have a certificate? Now this is just another text. It is not a certificate which needs multi-factor authentication or re-verification. Let's put it that way. So if I have this text, I can also authenticate this device with this certificate. Now I can authenticate more and more devices with this information once I extract it from the device, because these are the information available in this portal which requires me to log in. Let's put it that way. So I cannot log into the portal, but I can get the information from the device and spin up additional set of devices to send some malicious information. Let's put it that way. And then the system breaks. So I keep sending wrong information into the backend, and system can break.
One question.
Yeah.
But every device should have different kind of configuration, right? For certificate, or they will use the same certificate for the all.
So every device, you are right, every device will have a different scope ID, that's correct. But if I, let's say, steal this device, and then I replace it with my own device, connected from my home, can send any malicious data, right? So that is what I mean to say is that the moment you are kind of like compromising the thing with the connection string, you are exposing your backend. And when you expose your backend, you are not doing the right thing. And what we have introduced, just to give you a little idea about this device, because it is really hard for me to, one of you maybe can just pass it on to people so that you can just watch it. And then this has got some sensors which has got a accelerometer, gyroscope, etc. So it basically captures the information. So if I switch back to the internet which has got connectivity, let's see. Go visitor. Once it's connected, I can go to the dashboard, and you will be able to see that it starts capturing the information from this device, right? Does it require some special thing to set up? Go back to this. should connect. But while it is getting connected, let's just go back to that. So what we have seen is the device right now is powered by the USB cable, and you can see that we have got a couple of buttons. You can press the button also. Feel free to press the button. So that will send some random data into that. And below here, there are sensors available, humidity, temperature. So if you press one of these, so it will pick up your body temperature and humidity. It will change whatever the humidity of the room is, so that the graph will keep changing or fluctuating the value. So once this Wi-Fi is connected, I'm not able to connect the Wi-Fi. Oh, it's connected now. Good. Now I go back to this device where it is configured and refresh this page because it was not having internet connectivity earlier. You will see that data will start displaying. Okay, never mind. We'll refresh this page with a new login. You can see that the graph started displaying because it started collecting the data from the Wi-Fi I have configured. Now I can just enable a couple of additional views because this is moving, so it will probably have the XYZ axis, and also the humidity, probably some of the pressure, temperature might change. So you will find that some of you might want to shake the device also, so it will capture the XYZ coordinate, and this is sending the data. That's what I wanted to demonstrate here. Right? If you just shake it rigorously, you will see the gyroscopic thing will display that. Now this is how you generally connect. There is nothing extensive about it, and nothing advanced about it. This is a very common way how you connect your device to IoT connect. Now in this case, I am using something called IoT Central. IoT Central is a service available. Enables you to lay out the internal supporting IoT services available in Azure, so that you don't have to manually do it one by one. So you're thinking of like this is a template, right? You get a template and everything is deployed for you. You just have a connection string and go ahead and use the connection string, just like if you use the hosted database. Okay. Now I've got another device. Okay. So apart from this device, this looks same, and this device is, let me put the back box that way. So this device is known as Azure Sphere MT3620. That's the chip number. So it's a development kit, and it's the first device on the Azure Sphere family. What this device enables you to do a lot more beyond what the other device is doing, right? So this device, let me put the slide to explain. This device comes with MCU, microcontroller unit here, with a Linux operating system installed, and that Linux operating system is a custom built by Microsoft. So it's open source Linux, by the way. So we have taken the Linux kernel and modified it and put something. And then the device manufacturer used that operating system to put it in their device. And it has a hardware security key enabled, just like if you imagine the Windows world, you have got BitLock, which is very tied to hardware. Even if you take the hard disk out, you will not be able to boot that device from any other device because it is so tightly integrated. And then it has got a couple of additional pins, just you want to extend it with other sensors, like say humidity, etc. Because unlike the one which is getting circulated, has got all the sensors inbuilt, but this is just the bare metal device. And the back side of it, it has got a battery area where you can put the battery. And this is the device, as we speak today, is being used by Starbucks in Seattle for a testing purpose. So what Starbucks really does is that every machine they use in their coffee shop has got IoT. Okay? And then they have a recipe based on where the supply of those coffee beans comes from. So for example, if it is Seattle, definitely they are not supplying the coffee beans from New York. If it is in Bangalore, they are not supplying coffee beans from Europe. So supply has to be local, because then it will become the cost effective one and then more profit will come. They have a recipe and which keeps on changing because it's a constant research within Starbucks. It's a big thing. And then if you, let's say, have a new set of recipe, how do you really enforce those recipes into respective machines which has got a similar supply? Let's put it that way. What if a machine has got a minor difficulty and the machine is not working at the end of the day, so the store guy calls and Starbucks rolls a truck. They roll a truck, which is a very costly affair because they need to fix the machine, otherwise the business is not happening due to upload. So the architect of the guy, he came in the build conference. If you follow the build conference recording, you will find their case study, they are talking publicly. He's saying that the devices they procured for this pilot, there are hundreds of devices they procured, is the cost of one truck roll. So imagine that it's a minor difficulty which you can fix from remotely and just tell that just restart the machine or replug the machine or something like that. One truck roll is saved. So one truck need not come here, right? And that's the cost of all the devices they procure for the testing. That's the business benefit. So that's what they're trying today, and there are a lot of use cases, case studies publicly available. I highly recommend that. What it also allows is that it gives you something called Azure Security Service. That's the backend. That enables you to really secure. So all the enterprises, companies today use Active Directory for user login. Why they don't use SQL Server to save user ID and password? Because it's not secure, right? So they need some sort of service which will provide the secure user ID password. You can have multi-factor authentication and all sort of things to make sure that you are the right person who is logging to the machine which is connected to the local network. Same thing, Azure Security Service also enables you to do that. And then we have the Visual Studio because that's what the tool we use. So there is a tool available. So let me use that tool to show you how you can connect this device just like we have connected the previous one in the same portal. So let me connect this device. If I connect, it powers on, and then I just need one component which is Visual Studio tools for IoT Sphere. So if you just type here Azure Sphere tools for Visual Studio, you will get that installation. So developing Azure Sphere is the article which basically talks about how you can do that. So no, it's not the article. So it's the second one should be documentation. Yeah, setting up and installing. So if you see here, if you go down, little down, it talks about the extension you need in the Visual Studio. So you can either use Visual Studio 2017 or 2019. You can use either Community Edition, which is free, you don't have to pay anything, or the Enterprise Edition, which is paid one, for both Visual Studio 2017 and 2019. So Visual Studio free version can work with this tool. So you can try out with the free version of Visual Studio. Once you install this, what it comes up with a small command prompt. And you will see that called Azure Sphere. So this is basically a CLI. So let me just increase the size of the window. Now if I just type, so this is a CLI. So you can see that there are a set of commands. Now my device is connected. Whether the device is properly connected or not, you can see it from your device manager. So if I go to the device manager of this, and if I go to the ports, and you should be able to see these 3 ports, right? If I just see, you should be able to see these 3 things. If you see these 3 things, then your device is properly connected. At times, I was trying hard when I got the first device because we went to the lab, they gave us few devices, and then I came back to the hotel room and I tried connecting to the device and it was not connected. And I spent around 3 hours trying fixing that, restarting and doing all those typical Windows things. But what I realized is that I was using my mobile charger to connect the device. So they come with a different cable which looks similar, but if you don't use that cable, this 3 port doesn't come. It was accidental, but that was the case. So just in case you got this box and you were trying with some other cable, be aware of that. If it is not connecting, so go back to the default cable they provided. So this is
Now it is connected to my machine, so I will be able to configure this device with all those newer things. So let's put it that way. So let's put dev, that's a short form of the device, and it comes with additional command. And you can see that one of the commands shows that show OTA status. OTA is over the air, which means the operating system which is available in the device can be updated from Azure Sphere service. So today if you use some, let's say, when I got the device back in May, it was having X. Now over a period of time the new version comes in. Now I need to upgrade the device because when you use Windows, it is always recommended that your operating system has to be up to date. Right? The same thing with this device also, because it's an operating system. So to check the status, so I'll say show OTA status. It will tell me what is the operating system it is running. It should be 19.07 if everything is fine. So it's showing the operating system version is 19.07. You can see at the bottom of the screen. If you are at the back cannot see, let me know. I can just pull out that little more. Let's put it up. Okay. So you can see that it is there. Now I can, if I see anything which is not latest, it will tell you it's not latest. Now to update that, what you can do, you can just run something called recover. What this then it will do, I'm not going to do it because it takes few minutes. I have only limited amount of time. If you do the recover, it will start downloading the image into your local machine and start pushing those images into the device and then update the operating system. Pretty simple. Now I can also connect this device to a Wi-Fi. So you can see that there is a Wi-Fi. So if I say this Wi-Fi and I say list, just to check what all Wi-Fi's are there, I see a Wi-Fi which doesn't really valid here because it's my home Wi-Fi. So if I just go ahead and want to remove this Wi-Fi, so what I can do is that I can say delete, and I just need to pass the ID, that is -I and 0, and this will delete the Wi-Fi. Now next time if I run the Wi-Fi list, I will not be able to see the Wi-Fi. Now there is no Wi-Fi. Now I can connect the Wi-Fi which is available over here, and I say add. I don't remember all the commands, so I just type that and it says that dash is the SSID of the Wi-Fi, and then the dash is the key. So let's put that, right? So I'll say dash S and then say pro dash visitor, and then I say dash K, which is welcome @123. Okay, and after some time this Wi-Fi will start connecting. Right now it is saying that it is kind of okay. Now if I go back to the Wi-Fi and say list, this will start connecting to the Wi-Fi. So it is right now disconnected, but if everything is fine, it will connect. So it will show you the connected status as connected, right? After some time probably it may be trying to connect that. However, while it is trying to connect, what I want to also tell you that once you have the device and update the operating system connected to the Wi-Fi, the next thing is that you need to log into the Azure Sphere service. That's where the security comes. Because this device is not just the device, it is the device plus the backend. So if you are an employee of, let's say, this company, right? You are not an employee unless you log into the machine with your credential and the multi-factor authentication. It's not just the employee, I bring in anybody and that becomes an employee. So I can mask that employee, I can do all sorts of things. But that's not the way. So you have got a different level of security, additional level of security. Now, to do that, what you need to do is that you go to Azure Sphere and I say that Azure Sphere login. And this will prompt me to log into the tenant. Now, this tenant need not be your Azure tenant. It can be any tenant. It can be your Office 365 tenant, any tenant. And you don't need Azure subscription to do that, by the way. Okay? So you can connect to any tenant. So I'm connecting to my corporate tenant, let's say. And then once it connects, it will tell me that in this I have got few of the areas where I can associate my device to and get my certificate. That's basically my certificate service where it will provide the certificate. So that will certificate authority. Let's put it that way, because that could certificate authority, right? So you can see that all the tenants our colleague have created using the same Microsoft.com domain, hence I'm able to see. And this also is already connected, you can see at the bottom of the screen, is connected to the Microsoft tenant which I would like to use. So that's the tenant I'm talking about. This is the tenant. You can see that this is the tenant is connected, right? Otherwise, what you can do something like Azure Sphere and then say tenant dev and then say claim. If you do that, it will start claiming the device and it will attach the device with the device ID. You can see it's a big number, device ID, to the tenant. So now my device is kind of associated with the tenant. Even if somebody hacks my device and tries to extract the information out of the device, they will be challenged with the login. And that login is the login which I have provided. So that is not stolen yet. Okay, if they hijack me, they can do that. But let's suppose that device is only stolen, so they cannot take my ID. So it will be able to now retrieve the information only if somebody puts in that information, right? So what I now need is the certificate to associate in the portal. So what I'll use tenant. Now tenant comes with a couple of information called download CS certificate, and one of the things it says that the CF certificate file name should be .cer. So let's use this tenant download CS certificate dash, just put it that way. So it will say dash O is the output file name. So if I just create mkdir t1 and cd t1, that will go to the same directory, and I run this CS certificate dash O dot cert dot cer, and this it's fine, any file name is fine. Now it will create a file in that same folder, right? And then if you just do a ls, you will find the file is created in the folder at .cer. Interesting. So ls is taking a long time. So let's go back to the document, and there should be t1, and this is the file I'm talking about, right? Now using this file, I need to authenticate that device and connect back to my IoT Central. So let's try doing that. So you remember that how we connected the same MX chip. So I'll go to the device, and I've got another template which is basically a blank template where I can add Azure Sphere device. I say I want to add a real device. Now when I add a real device, first of all I need the ID which it populates. So I need to pick up the ID, which is the ID which came sometime back. So this is the ID, and I need a smaller version. So let's just use the shell v equals to lower, yeah, crude way of doing things. Okay, so I'll just put it that way and just I say create. So this device is getting created. Now it is not connected. So to do that, I need to click on connect. Now when I say connect, it gives me a few things: scope ID, device ID, and the certificate. Now I can use the certificate. Now you can see that this is telling verified because I did it before, but imagine that it is not verified. Now what will happen if I create a new device? Let's create a new device. Okay. Let me just okay. So let me go back to the administrator, device connection, and I will go to the certificate and I view it, and let's say I generate So this is not Azure Sphere. So let me go back to that. Device, Azure Sphere. This is the device. I don't know why it is going back to the max chip, but let me just put it that way. Okay, so let me go back to the certificate I generated. Okay, put that documents T1 cert. Okay, now once you put the certificate, so ideally you should be seeing this too as blank. It says need verification at the bottom. I just wanted to highlight that. Now, not just you need the certificate, but also you need the validation. Now, how the verification can happen is by re-authenticating that device back to the same AAD which I'm using. So let's do that process. So to do that, you need a verification code, right? So I'll put this way, and I generate a verification code. So a code gets generated, the verification code is generated. Now I need to produce another certificate which will, with this verification code, so that it is having a handshake, right? So I will go back to my command prompt, and I say that Azure Sphere tenant, and one of the commands is download validation certificate. This is the certificate I need. So I will use this, and I put it this way, and it has two parameters. One is the output file, and then another is verification code. So my output file is .o, and then I say vcert, that's a verification cert, and .cer should be the file name, and then I have got a code. Let's put it shorter one, verification code. That's a code which got generated. Okay, so I will copy this code from here, I will paste it, and this will produce another certificate. That's a vcert, that's a verification certificate, and it will get downloaded into my machine. Now using CLI, it means that you can be DevOps enabled, so you can do it all through command, which I'm doing. Now what I need to do is that I need to go and say verify. If I verify, it will ask me to provide the validation certificate which I produced, just the vcert. So I'll pick up the vcert, not the cert. If everything is fine, then it will tell me that it's verified. You can see the green checkbox. That's how you connect a device. That's different from what we did earlier, right? And this is not easy. So even if this device is compromised, nobody can connect back to my backend, provided they have the credential also to connect to the same AAD. And the credential to connect to the AAD requires multi-factor authentication. I am using multi-factor authentication because it's a corporate laptop which has got a certificate associated. If I am, let's say, connecting from Anand's laptop, it will ask me to either use a text-based authentication or a call-based or an app-based, depending on how it is configured, and I have to respond back to that to verify that. Now it is connected, right? This is now connected with this kind of thing. Now if you want to really deploy the code, I don't have time to deploy the code, I'm already 2 minutes late. But if you deploy the code, it can start capturing the information just like you have seen before. Now, few things I just would like to let you know here, that when you use Visual Studio to deploy the code, let's put it that way, there are a few things needed. You can do debugging directly into the device, and if you open the code, and these codes are available in GitHub, by the way. I've shared the slide with Anand, it's in my GitHub, and then in the last slide it has got all the links to the GitHub link. So remote debugging. Now if I click on that, it will throw me an error because this device, even if I'm using at this point in time in my local machine, is not activated for the development. So I need to also provide the certificate back to the device for development purpose. And to do that, you have a small command in this which says that Azure Sphere dev, and then it says that prep debug. Now there are two commands. One is prep debug and one is prep field. Prep debug means when you are doing development, you can prep debug so that you can deploy the code and do a live debugging using Visual Studio, put a breakpoint. If you make it prep field, this is locked, no side loading allowed. Okay, so it's a production ready device, let's put it that way. So you should ideally be making a prep field so that it's locked down, no side loaded code can be enabled. It's just like, I'm not sure how many of you do the phone development. So when you do the phone development, your developer phone is unlocked, developer unlocked they call it, so that you can put any APK file into that and then test it. If it is not unlocked, right, let's say iOS kind of phone, then you will not be able to deploy any application into that. So I just say that device prep debug, and then this becomes ready for my debug, right? And it is basically telling that it is downloading some certificate and putting it to the Visual Studio. So Visual Studio understand that all the blah blah thing happens, you don't have to worry about it. Just a single command, and once it is kind of done, it will reboot the device and make it ready. Once this device is rebooted, you can go back to the Visual Studio and say deploy. It will deploy the code in the debug mode, right? Right, you can see that it is saying that some packages is getting to the device and then successfully done. Okay. Now if I go back to the Visual Studio, now I should be able to remote debug. This code should go. Let me just, okay, it is not yet connected because I have to provide the manifest file here. So let me just, so you need this couple of information. Do I have time to do that? Do I have time? Huh? Okay. I will try to do that. So you need few things. You need this AAD information. Let's pick it up. I need this one, I need the other few things also, so I will go to the dashboard and then I need scope ID. This is the scope ID here, and then I need this device ID. I need one more thing here. So to do that, what you can do, I will go back to the code, and in fact in the GitHub you will also find this tool. So if you go to the code, there is a section called tools, and in that tool there is a exe. So let's open a command prompt from here, and then that is show IoT config.exe. Yes, it will connect to the same IoT Central using the credential. If I put the credential and get me few additional details, so which I need to put in the file. Okay, it did not, so let's skip that part and then use this one to fix. We will try to see if it can connect. Sometimes some command prompt doesn't work, so I have to switch to the CLI. So ideally it should stop here and ask me to choose, so which is not doing, but otherwise let me just try one more time and see if you are lucky to have it. No, it should stop here. My cursor should stop here. and it's not stopping. So if it stops here, then I will be able to pick up 1 out of 3 where I have deployed this code to, and then it will get me few more additional information which I need to put it in the config file, which I can also manually get. However, the whole idea is that the code which I am showing here is kind of readily available code written in C and C++, which can be deployed into the code. Now this supports only those basic languages right now. So if you are building some application, you need to use those languages to build the code, right? I think you got the idea, like about the security, what is the major difference between any other Raspberry Pi kind of device versus the Azure Sphere, right? That's the difference, because you need to have user login attached to it to be able to read and write to the device. Okay? Yep, with this. Yeah.
Yeah, I have a question. This is for the single device. If there is multiple devices around doing something, so do I need to do it in individually? Is all configuration?
So ideally in the production kind of scenario, these are being configured by the OEM vendor. So they have the information, they do it when they load those devices. In the production kind of scenario, if you have to do it, or let's say reconfigure it, put it that way. So once you get the device, you put it in the production and you have to reconfigure it. We have a service in Azure called a device provisioning service. Using the device provisioning service, you can do a mass deployment. Just like in the corporate world, we use Windows provisioning, right? IT manages Windows from a central location. You can also manage your hundreds of devices from a central location using the device provisioning service and push the latest update and all those things. Even the code scenes, let's say a new version of the application comes. So how do you push those code? Because that code needs to land in that device, right? So all these things you can do through the device provisioning service.
This device is directly coupled with Azure, right? Azure services.
It's not Azure Sphere security service. Even if you don't have Azure, you still fine with that.
Okay, so I can use as a Raspberry Pi?
No, because the Raspberry Pi is not an Azure Sphere device. It's Azure Sphere operating system. So the chip is very specialized chip with a specialized operating system installed into it. So Raspberry Pi is a free device which you can either install Windows or Linux version.
Okay. How monetization or payment model works here?
You use the backend. In case that will be Azure backend, let's put it that way. You put the data, you use our compute to run your algorithm, do a big data analytics. So that's the business what Microsoft does. And the business which device manufacturer does is by selling those devices.
What are the cost of this?
So I don't know the production cost because it's still under preview. What is the actual production cost, I'm not aware. But it is not a significantly high from the typical MCU device because the operating system, everything is free. We don't charge for that because it's a Linux operating system. So ideally, if the manufacturer is okay with their production and then just deploy the operating system, that should be fine. So there is no additional cost required.
I have one question. This login configuration, you can do from the portal or you can do it from the code. Like the one you use the tenant ID to connect it. I mean, I've worked on the normal web applications. Then to connect it, you provide the tenant ID, client ID, and then you validate that. So this login thing, how you configure this? That this device should be logged into your.
So you mean to say that when you do a automated way of doing it, how do you do that? Okay. So here you definitely in the CLI you need a human interaction, where in Azure world we call it a service principal. It's like a service account, non-human account. So you can provide the service principal, which is like an application using what, right? On behalf of that, somebody else will authenticate. So you will have an application ID, application secret. Using that, you will get a token and a refresh token, and that's how the authentication will happen.
You can use a similar thing.
Yes, you can do that.
Yeah, because you're using the similar thing in the coding and
Yes.
the .NET code, so you can do it.
Yeah. So if you see here. What I'm using is a development CLI, so I'm not sure if this will have. It doesn't provide those. No. This command doesn't provide those things, but you can ideally log in using your service principal and get the token back to the device.
Okay, so
Yeah,
you can.
yeah, you can do that. Yeah, ideally that should be the case. right, so any other question from anyone? Oh, I just taken almost 15 minutes. So thank you very much. Hope it was okay. You enjoyed that.